Recently, I made a video called "When this video gets 10 likes, you get bonus content." Well, thanks to you guys, that video hit 10 likes in record time, faster than any other video I've ever made. So thank you for doing that. But obviously that means I get to make an extra video for you. So this is that bonus video. I decided to talk about average velocity over a period of time, which is basically just average rate of change over a period of time. And I decided to mix it up a little, do something a little different than I normally do. So I tried a little bit different video format in order to show you this example of average velocity. So let's go ahead and just jump right on into the problem. So here's the problem we're going to be going over today. If a rock is thrown upward on the planet Mars with a velocity of 10 meters per second, its height in meters, t seconds later, is given by this equation. Y equals 10t minus 1.86 t squared. And basically what we're going to do is we're going to find the average velocity over these given intervals. So actually in this video, I'm going to show you exactly how to do part A. And then I'm going to leave part B and C up to you so that you can get some practice on how to do these. But it's going to be the exact same process. And once I go over part A, you should be pretty good with part B and C. So when you're doing a problem like this, the first thing you want to think about is the difference between instantaneous and average velocity, because those vocabulary terms are calculated very differently. Instantaneous velocity means that you're basically finding the velocity of an object at a specific instant. So you can kind of think of like at the snap of a fingers, how quickly is a certain object moving? Usually to find this, you're going to have to find the derivative of some position function or height function or something like that. And you're going to use that derivative to find the instantaneous velocity at a specific instant. However, in this problem, we're trying to find average velocity. Average velocity means you're finding, as it says, the average velocity of some object over a period of time. So keep in mind that key difference there. Instantaneous velocity is at a specific instant. Average velocity is over a period of time. So in an instantaneous velocity problem, you're given one specific t value, one specific time to look at. In an average velocity problem, like the one we have, you're given two time values because you need a range of time from 1 second to 2 seconds, for example. And this is pretty much just going to be used found in the average velocity formula. Well, to figure out what that average velocity formula is, first of all, you want to think about what velocity is in general. Velocity is basically a synonym for speed. Speed and velocity are kind of the same idea, especially in calculus. But velocity or speed is just distance over time. So distance an object travels divided by the time that it takes to travel that far. Well, in this type of a situation where we have this function, y equals 10t minus 1.8t squared, we know that that tells us the height of this object after t seconds. And we're looking at two specific time values, time 1 and time 2, in order to find that distance that it travels between those two times and the amount of time it takes. You basically just want to take the height of the object at your second point in time minus the height of the object at your first point in time, and that basically tells you how high it moved, either up or down, basically the distance that it moved between those 2 points of time. And then you're going to divide that by the second point in time minus the first point in time, and that tells you the amount of time that elapsed between those 2 points in time. So basically the difference between those two, y2 minus y1, tells you the distance that it traveled over those two times, and then t2 minus t1 tells you the amount of time that passed over those two times. And then if you divide those, that obviously gives you the velocity over that period of time, the average velocity over that period of time. So what that looks like in practice, we have, in this case, part A, we're trying to find the average velocity of this object with this height formula, which tells us the height at time t, the average velocity that it moved from time 1 to time 2. So we're just going to use that exact same formula that we had before, y2 minus y1. So the height of our object at time 2 minus the height of our object at time 1 over time 2 minus time 1. So to do that, we just plug in t equals 2, which is our second time value, into our height equation. And then we plug in t equals 1 into our height equation and take the difference between those two. And that's exactly what you see on the numerator there. Plugging in 2 and then plugging in 1 and then subtracting them. And then you're going to divide that by, again, our second time value of 2 minus our first time value of 1. And doing this calculation is going to tell you that the average velocity of this object over that period of time is 4.42. And then you probably would want to include units on there. The units is just going to be whatever your distance unit is divided by whatever your time unit is. So that's just going to be meters per second. So from 1 second to 2 seconds, our average velocity is 4.42 meters per second. So like I said, it's going to be that exact same process. Go ahead and give part B and part C a try. You can just rewind the video back a little bit and get those other two parts, and let me know if you're able to get the answer in the comments below. If you're able to get part B and C, be sure to drop a comment below letting me know that you got it. And if you like this video format that I did with the slideshow, let me know in the comments below as well. And give this video a like so that I know you like this kind of content, and I'll be able to keep making more for you in the future. Thanks, and see you next time.